For this set of material, we're going to start asking questions. So essentially, it's based on the idea of, if this happens, do this. If that happens, do this. So what we can do is we can start to compare values. So our first set of comparisons that we can make are using relational operators. So these are less than, greater than, less than or equals to, greater than or equals to. So I have 4 options. Note less than or equal to. This is less than, equal, no spaces. Same thing here. It's greater than, equal, no spaces. I can also compare things to see if they are equal to each other. So using my equality operators. There's 2 of them. There's equals to, which is 2 equal signs. 2 equal signs. The single equal sign is the assignment operator. And we've been using it since the beginning. Store this value in this variable. The double equal sign is equality. Check to see if the value in this is equal to the value in that, if they are the same. And then I have not equals to. Once again, it's the tilde, which is right next to the number 1, and equal sign, no spaces. And what's going to happen is we can compare 2 values, 2 variables. So var, compare, var. And the answer is going to be illogical. My answer is either going to be true if that comparison is true, or false if that answer is false. That's where our answers come in. Typically, we are comparing numbers, so typically these variables contain numbers. We can also compare text as well. If you are comparing single quote text, you should use string compare or string compare I. If you don't care about case, if it's not in case insensitive. So this is single quote strings. Because remember, single quote strings are arrays. So there's just some caveats with that. However, if you have double quote strings, you can use these comparators. I will demonstrate single quote strings in class just because that's what I've done in the past. I don't know, maybe in a future version of class, I'll do double quote strings. So that's our first set of comparisons. Our second set of comparisons is logical, using logical operators. So this is logical and, logical or, logical not, and logical exclusive or. So these operate on logical values. So we're talking about true or false, and true or false. So and is going to be true if both of these are true. Or is going to be true if only one of them is true. Not makes a true false and a false true. And then XOR is true if they are different. So there's something called a truth table that I have down here that essentially outlines what happens when we do ands, ors, XORs, nots. So if our first operand, if the left-hand side is a false and the right-hand side is a false, if I AND those two together, I'm going to get false. If I OR those two together, I'm going to get false. If I XOR those two, I'm going to get false. And then if I negate this first one, I get true. Same thing, same idea. So if my first one is false and my second one is true, if I AND those together, I'm going to get false. If I OR those together, I'm going to get true. If I XOR those, I'm going to get true. And if I negate the first one, I get false. So here's my truth table that essentially outlines that process. There are two different ands and two different ORs. So double ampersand and double bar. The bar is the other symbol on your backslash key underneath backspace and enter. So this is and for scalars. This is or for scalars. A single and a single bar, these should be used for arrays. And what we're going to do is we're going to take logical operators. We're going to take our relation operators and equality operators to start comparing values and asking questions.